We're going to talk about division with fractions. And to start off, let's talk about what reciprocal means. Reciprocal means I'm going to take a fraction and I'm going to flip it. I can take a whole number and flip it. The only time that this won't work is if you have zero. Zero is over one, will not be as, will not equal one. That's just not going to. You won't be able to flip it as 1 over 0 because that is undefined. Okay, so 0 has its own little rule here. All right, so it doesn't have no reciprocal. It's just 0. Right, now, if I had this number 2/3 and I told you I wanted you to give me the reciprocal, I'm going to flip it. That's what it's telling me. 3 over 2. Why is that? Because when I reduce 3 over 3, I get 1, 2 over 2, I get 1. And we're going to apply this rule here in just a little bit. The next one says we have 10. Well, a whole number is seen to be over 1, but we don't write it that way because that's not the simplified form. However, when you're writing it in, writing the reciprocal of it, we're going to flip that and it becomes 1 over 10. So let's start by dividing. If you want to take a moment and pause this and take down some of these notes at the very beginning, go right ahead. I'm just going to jump right into actually applying the method. So whenever we're dividing fractions, I mean, you can have a whole number divided by a fraction, however it may be, as long as there's at least one fraction involved in the division, then we're going to apply this rule. And this rule is we're going to keep the first term the same. We're going to change the operation from division to multiplication, and we're going to flip the last term, the second term. We're going to find its reciprocal. So I'm going to come over here and I got 4. Whoops, a little early. You flip the second. Sorry. You rewrite it. I got 3/4. I'm going to change division to multiplication, and I'm going to flip that last term to 3/2. Right? Because it was 2/3. Okay. Now I'm going to ask myself, is there a number on top that will reduce with a number on bottom? Well, on top we have 3, and on bottom we have 2. So we can't do that. So we're just going to multiply straight across. 3 times 3 is 9. 4 times 2 is 8. That would be my final answer. It is an improper fraction. If you were asked to convert it to a mixed, you could. We're going to save that for the next one. All right. Scoot that down. That's a different example. So let's divide this one. We have a proper fraction divided by a mixed number. So before I apply my rules, the first thing I want to do is I want to rewrite this mixed number to a improper fraction. So let's go ahead and write everything down. The denominator does not change here. However, I'm going to say denominator times that whole number. So 9 times 2. And we're going to add it to this numerator, which is 8. So I got 9 times 2, right? That's 18 plus 8 gives me 26. Now we're going to do the keep, change, flip. And I'm going to reduce. Well, 16 is made up of what? 4s. That's going to be 4 times 4 over 27. Well, that's 9 times 3 times, well, I'm not going to reduce that 9 because I got a 9 here, right? They automatically reduce. 26 is going to be 2 times 13. So what I see here is this 4 can be 2 times 2, and I can reduce one of them. So always reduce if you can while the numbers are small. You get big numbers, you might not reduce all the way. So now I'm going to rewrite it. 4 times 2 times 1 over 1 times 3 times 1 times 13. This 2 here became a 1, so you can write that here too as well. 4 times 2 is 8. 3 times 13 is 39. That's a proper fraction, so we're not gonna rewrite that. That's division of fractions.